and what are the type of problem that we can encounter in general. And we saw how also like some problem can be very sensitive to initial solution. Okay, so this problem will be hard to treat numerically. So we'll give example about problems like this numerically. Now, we saw also the Euler method. So the Euler methods consisted of, are you seeing the screen?
Yes.
Yes.
Okay. So the Euler methods consist of, so yi plus 1, you construct the point yi plus 1, okay, as yi plus h of xi yi. Right, so, well, of course, yi plus 1 is, this is y of xi plus 1 and xi plus h. Okay. And this is the solution of y of x, y prime of x equals f of xy, right? And we show that there is 3 methods of deriving this this Euler method. Several methods. The first one being from the Taylor expansion. So if you retain only the first order of the Taylor expansion, okay, for the derivative here, okay, so y at xi plus h is y of xi plus h f prime, okay, of xi yi plus higher order term, and this is, okay, the first order term. And you can also derive it from the left, okay, from the rectangle left corner by converting the here derivative into an integral. So y of x is the integral, okay. So y of x I plus 1 is the integral, is yi plus the integral or xi till xi plus 1 of x f of x y, f of x y of t, f of t y of t, okay, dt from so from infinity to x, but here it's from xi to xi plus 1, okay, because we're calculating at xi plus 1. So, and by retaining the rectangle methods, you get, okay, you get here this expression. Okay, so now for the higher order methods, so if we want to generalize this to higher order methods, okay, so the higher order methods can be also derived from, for example, higher order, okay, Taylor expansion. Okay, so for example, here y of xi plus h, okay, so I will put here higher order Taylor expansion. I said the order is based on the first order. Okay, so y of xi plus h would be y of xi plus h, okay, y prime at I, which is, this is f of xi yi, okay.
دكتور سؤال.
Yes.
chapter 3 و 4 و 5 ما عندهم شي PDF أو شي slides؟
What?
هلا هذا chapter 5 مزبوط؟
Yes.
3 و 4 عندنا في slides أو شي PDF إلهم؟
3 4 yes. ال 4 عنده، 3 ما عنده. So So basically
ال3
this square
نزلته.
ما عنده. Okay. And الفور عملت لكم واحد PowerPoint, so I made a PowerPoint, but الفايف هلا هو like the course is not was never on PowerPoint. Okay, so I was always doing it on the board يعني. بس هالسنة يعني for exceptionally عملته on PowerPoint to make the videos and things like that, but no, generally there is no PowerPoint. So okay, so PowerPoint دول عملتهم بس هالسنة أنا.
ايه
So
اوكي، بس عم بسأل لان منه بين ايدينا الشابتر
بس
4.
take notes يعني take notes يعني you will have the videos. Take notes, rewrite this on you know, like on a notebook.
اوكي.
Okay, so because like these things, it's better to write it, so when you write it you understand it. I'm like this. Like if I want to understand something, I prefer to write it down so I can understand it better, right? So, and now if I want to, so I will send you the PowerPoint for the chapter 4, the rectangle, which is available on YouTube now. All right, so I should add it to the list, to the playlist, numerical analysis بعد ما زدته على playlist. But no, it's available. If you look at it on YouTube, on my channel, you will find the video, right? You will find it's in 4 parts, I think. The
اوكي.
chapter 4. chapter 5 بعد ما بعت لكم اياه. هلا اليوم ببعت لكم اياه مع this part. Okay, so d over dx. Okay, the second derivative, so y second. Okay, so I'll put here y second. So this is here y second at I. What I mean at I is the point xi, right? At xi plus 60. Okay, so here this is what f of x I yi. Okay, because y prime is f of x y. Okay, and here in this case y second as the derivative d over dx of f of x y. Okay, هلا what you have to know is that the y depends on x. It's a function of x, right? So when you want to make the derivative d over dx of f of x y, okay, so you must derive its df over dx by dx over dx, which is 1, okay, plus df over dy by dy over dx, and dy over dx here. This is okay, plus df df over dy, sorry, here, yes, df over dy by dy over dx. Okay? So basically this is equal to f prime of x, the derivative, okay, of f per respect to x, because f is a function of 2 variables, okay, x and y. Here they are just with respect to x, and plus f prime of y multiplied by y. Okay, because f prime of y multiplied by f, sorry, okay, because dy over dx, this is f of x y, and this is the derivative of this function with respect to y, so I will call it here f prime of y multiplied by f. So you get as an expression here, okay, that y at I plus 1 يعني xi plus h, okay, is y of xi, y يعني yi, okay, plus h of f of xi yi plus h square over 2, okay, f prime x, of course it depends of xi yi on in xi yi, right? Because this is the second derivative here, okay, on xi yi. So this is this function on xi in the at the point xi yi plus f prime of y xi yi, okay, depends on xi y, f of xi y. Okay, so this is the Euler here, right? The Euler method, and this is a higher order term. So this is more accurate than the Euler. It retains the second order Taylor expansion. So the error here is of the order of h cubed. Okay. Now, as an example here, okay, for example, okay, if we take the example y prime of x is equal to minus xy that we considered before, okay, the solution of this is a Gaussian. Okay, so this is the f of xy, right? Okay, so here for this scheme, okay, you get, for this problem, you get yi plus 1 is equal to yi plus h of xi yi. Yani here, the f of xi yi is, okay, minus xi yi, okay, plus h square over 2, okay, minus yi. So the derivative with respect here to x, so it's y at the points xi, okay, it's yi, okay. Remember that y is a function of x, okay. So minus xi, okay, f of xi y. So as you see, this is now as the Euler, okay. The Euler is an explicit method, okay, that you calculate. So if you have the first point y1 equals, you have the initial solution, the y1 that is equal to y of x1, where x1 is your first point here, the initial solution, okay. So you discretize your interval into several points, and if you have your initial solution, okay, in physics you always, I mean, the problems are problems of initial solution, for example, initial velocity or etc., or initial position, and then, okay, you calculate the second point from the first point using this for the Euler, and this is a higher order, okay, expression, right, that involves the second order term, okay. But it's also, these two are explicit methods, okay, because the calculation of the points at the next step is immediately, okay, obtained from the previous points. So first I calculate the second point, then the third point, then the fourth point, and etc., 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 and then I get my function here, okay, y of x, So you get here what you get with the numerical method is okay, the points yi, right? So, but of course, I mean, when you interpolate, you get your function, all right? So y of x. So numerical methods can only obtain, okay, some definite point here, discrete points of your function y of x. Okay, but of course, if you take a lot of several points that are close to each other, then you get your function. I mean, you get almost as good as a continuous, okay, variable, because they will be very close to each other. The points, the discretization points, right? So
Mhm.
this method is an explicit method. It works, but the problem of this method that it involves calculation of these quantities. So for any given, I mean, for every given function, you need to calculate. So if you have a different function here, f of x, y, you need to calculate these quantities, right? So we will see other methods that you don't need to do that. Okay, so this is the disadvantage of this method, that here you need to calculate this. Okay, the f prime of x, f prime of y, and for each function f of x, y, it's different. عم تسمعوني؟ Hello?
Yes, yes.
Yeah?
Yep,
Yes, doctor.
Is it clear?
it's clear.
So now let's consider another. I mean, this method was derived from higher order Taylor expansion. So let's take, instead of taking the rectangle integration, let's say let's take the trapezoid integration. Okay, so a method derived from trapezoid integration. Trapezoid integration. Right. So basically, you have that y prime of x is equal, okay, to f of x y. Okay, as we said, when you integrate, okay, this means that y of x is equal to the integral from minus infinity to x of f of t y of t, right? But y of x I plus 1, okay, now if you take you cut into your integral, so you get it. So last time I didn't derive it completely. So this means that y of x is the integral. This is the definition of a primitive, right? Okay, of f of t, y of t. Okay. Now, if I take y of xi plus h, right? This is the integral from minus infinity to xi, right? F of t, y of t, dt, plus the integral here. So y of xi plus h is the integral from minus infinity to xi plus h, right? Okay. But now if you separate this integral in two, you take from minus infinity to xi, and then from xi till xi plus h, right? Here, so f of t, y of t, okay, dt. So this is here y of xi, so it's yi, okay. This is yi plus 1, and this is yi, okay. And this here for the rectangle we approximated as, okay, the integral from xi till xi plus h, f of t, y of t, we approximated by one rectangle, which is h f. So we have 2 points, right? If f of, okay, the rectangle integration using just 2 points, xi, yi, so the left corner rectangle integration, right? So this is what we did here for the rectangle. Now instead of the rectangle, let's take the trapezoid. Okay, so here if I replace instead of the rectangle the trapezoid, what do I get here for this integral? I'm waiting. Hello.
مش حافظها.
What's the
It's
integral
two
of the
terms.
trapezoid? So if you have here, right? So this is xi plus h. Okay. So this is f of xi, f of xi plus h. Okay. What is the area of this trapezoid? I should have. It's just the trapezoidal integration using 2 points here. Okay. So أحسن شوية لما كان في trapezoid. Okay. So.
So f of xi plus f of xi plus h. No,
Yes.
f of xi plus h minus f of xi.
No, keep. So this is
No,
f of
okay.
xi.
F of xi, as in the first
F
base.
of xi plus h.
F of xi plus h second base times the height اللي هو f xi plus h minus f of xi.
No, the
No,
base,
xi plus h minus xi, sorry.
h.
Which is h. Over 2.
H over
No.
2.
Yes, okay.
Yes. F of xi yi, okay, plus f of xi plus 1 here, yi plus 1. Okay. This is this at xi plus xi, and this is this at xi plus 1. Okay, for we had xi, f of xi plus f of xi plus h over 2 multiplied by h, the height of the trapezoid. So here you get, if you express this, you get yi plus 1 is equal to yi plus h over 2 f of xi yi plus f of xi plus 1 yi plus 1. So this is an implicit or an explicit method here. As you can see here, this is an implicit method. ليش؟ لأنه هنا عندنا f of xi plus 1 yi plus 1. So this here, okay, you don't obtain, so you have yi plus 1 is equal to something, a function of yi plus 1. So you don't obtain a direct relationship here. So you have to solve a linear system, a linear equation here. And and for each step you need to solve a linear equation. Okay, so this is an implicit method. It requires solving a linear, non-linear equation. Sorry. يعني you need to solve a problem of the type, okay, I will not say f of x equals 0, I said g of x equals 0, okay? Or big f of x or capital F of x equals 0. يعني, capital, okay, so you need to determine, okay, the point xi plus 1 satisfying this equation. For example, okay, let's say that if your f of xy is minus xy that you considered before, here you get yi plus 1 is equal to yi, right, plus h over 2 xi yi plus, okay, xi plus 1 yi plus 1. In this case, okay, in this case, I took a bad example here, because in this case, it becomes an explicit method, because you can express yi plus 1 in function of, so in
xi,
this
yi.
case, okay, you can express yi plus 1 in function of yi. So if you bring this here, the xi plus 1, you know it, okay, you know the xi's, you know them, so you can bring this here. But in other cases, let's say we had here y squared, then you need to solve a linear system of equation to determine this, a linear equation to determine this y plus 1, okay? If you have, for example, here minus x y squared here, okay, you have I plus 1 is equal to yi plus 1 square. So you cannot directly determine this. So you need to solve an equation of the type here, okay, f of x equals 0, or, and the solution here, yi plus 1, is the solution of this equation, right? So you need to determine the solution of yi plus h over 2 xi yi. كل هيدول عنا يون xi yi. For example, for the point, for the second point, okay, let's say we have y1, okay, x1, y1, we have them, but we don't have y2, right? So for determining the y2, we need to solve a nonlinear equation, or, okay, of the type f of x equals 0, okay? Okay, I'll write capital F of x equals 0, right? So if you don't, okay, confuse this f with this f. So so here you will have, for example, plus h over 2, okay, plus minus yi plus 1, okay, minus, right, yi plus 1 square xi plus 1. So you need to solve here, okay, equals 0, okay. So you need to solve here the solution, the xi plus 1, okay, is the solution of this f of, okay, x equals 0, okay. Now, so this is an implicit method, like as we saw, okay, determining or deriving higher order methods from, let it be higher order Taylor expansion, or from higher order integration, right, poses some problem here, because here we got an explicit method, for example, but it's, you need to calculate these quantities, and here, for example, you got an implicit method. So that's why we will introduce now the Ranch-Kuta methods. So the Ranch-Kuta methods are the most used explicit methods, and there's two different methods of order 2. Yani, this is the method of order 2. Order 2, yani, it means that it's equivalent to a second order Taylor expansion, right? And there is one of order 4, right? So a method of order 2 has an error of h cubed, an error of order 4 has an error of h5. So that we note range kuta methods of order 2, RK2 and RK4. Okay, so I think it's 5, 6 here. Now range kuta method. Still hearing me? Everything is good?
Yes, yeah.
Okay, so the connection will, I think it will stop in 1 or 2 minutes. عندكم شيء بعد الصف؟ لا. You don't have
معتاد
another.
عندهم English at 3.
بلا في انجلش دكتور.
Now, no, the thing is that the Zoom meeting will stop and I don't know if I can add 10 minutes more. Type, it's okay. We will continue next time. Now, as a task, right? I'll give you a task to do at home. Okay, so write a program that solves, okay, y prime equals minus xy with y of 0 equals 1 using the Euler method.
Okay.
And you have to define here a vector x, okay? Let's say you take x between 0 and 1, right? You can take any here, and you define number of points, n points, or n sub-interval, okay? Using n, for example, equals 100 sub-intervals. You define your vector x, and then you start from, okay, y equal of 0 equals 1, it's y of 0, but it's, you don't have to confuse between y of 0. 0 is the first point. In MATLAB, you write y of 1 equals 1, because this is the, y will be a vector in MATLAB. Okay, you don't have to confuse between the analytical notation y of 0, yani y of x equals 0. This is, what does it mean? Equals 1. Okay, and y of 1, yani the first index, because x equals 0 correspond to the first index 1, all right? So from 1 till n plus 1, if you have n sub-interval here, you have n plus 1 points. So you define a vector x, and then knowing the initial value, you solve y prime is equal xy minus xy using the Euler method. Think about it, right?
Doctor,
Okay.
Yes.
Doctor, do we solve it and send it to you over via mail?
Yes, yes. Send it on the UL mail. Don't send it on the Gmail, right? Because I have so many mails on the Gmail that I'm overloaded and I cannot even see your mail. Send it please on the UL. Send it on
Okay.
this.
One more thing, Doctor.
Right?
Could you
So
please take a picture of the task and send it to us on WhatsApp?
you want that I take a picture on the task and that I send it to you on WhatsApp?
Yes, please.
Right. Yeah. Okay. Yeah, I will rewrite if you want better.
Thank you.
Okay. I will. Okay. So that's what you have to do for next time, all right? So and we will see explicit methods that are called the Ranch-Kuta methods, and there are more advanced. I mean, there are explicit methods that are the Ranch-Kuta of order 4 is one of the most accurate methods. Okay. And we will see how they behave, okay, when you according to the convergence, okay, compared to the analytical solution. Yani when in hard cases, okay, where for example the initial solution is not okay, where the error increases exponentially with the initial solution, okay, as the example that we previously gave last time. Okay, so we'll stop here and see you next time.
Okay.
Thursday,
Mhm.
right? So I'm trying to finish this
Okay.
chapter. Yeah.
Thank you.
Bye.
Bye bye.
Thank you, Doctor. Bye.